Hello students, good morning. Hello everybody. This continuation class of heights and distance from class 10 mathematics and myself Pradip sir in front of you. Students, in the previous session we have learnt about the angle of elevations and angle of depressions and how to find the height of any elevated object or distance of a point from a elevated object like tower or a tree or pole, whatever it is. So we know how to find those things. Actually, in height and distance we have to draw right triangles, and then using the concept of trigonometry, that is perpendicular upon hypotenuse is sine theta, base upon hypotenuse cos theta, perpendicular upon base is tan theta. So using all these things we can easily find the height or distance. Okay, so in the previous session we have solved two problems. Hope you have understood those two sums. Today I am going to show you some different types of sum, that this is also related with heights and distance trigonometry. So let me explain how the things goes on and how we can find all those heights and distances. Okay, so here the first question is, a 1.5 meter tall boy is standing at some distance from a 30 meter tall building. Let me write down the question, it will be easy for you to understand. A 1.5 meter tall boy is standing at a distance of from a 30 meter tall building, at a distance from 30 meter tall building. The angle of elevation from his eyes to the top of the building, the angle of elevation from his eyes to the top of the building, increases from increases from 30 degree to 60 degree as he moves towards the building. The angle of elevation increases from 30 degree to 60 degree as he moved towards the building. Find the distance he walked towards the building. Find the distance he walked towards the building. So just go through the question. A 1.5 meter tall boy is standing at a distance from 30 meter tall building. The angle of elevation from his eyes to the top of the building increases from 30 degree to 60 degree as he moved towards the building, as he walked towards the building. Find the distance he walked towards the building. So first of all, with this given information, we have to draw the diagram, because without diagram we cannot solve any problem related to heights and distance. So first of all, we have to draw a 30 meter tall building on the ground. on the horizontal level. This is the horizontal level. This is the building whose height is 30 meter, and this is the boy whose height is 1.5 meter. Now from here the angle of elevation of the top of the building is 30 degree. Now see, let me mark the boy as AB and the building as CD. Since the boy is looking from the point A, that A is the point of observation, so we have to draw one horizontal line from A parallel to the ground, horizontal level. Now this gives the angle of elevation, so it is 30 degree as per the question. When we were standing, when AB is the position of the boy, then angle of elevation was 30 degree. Now the boy is walking towards the building, towards CD. At certain point, suppose the boy is at this point, let the point be EF. EF is the position of the boy, and from this position, when he look towards the building, the top of the building, the angle of elevation becomes 60 degree. So this is angle of elevation at this point, which is 60 degree. Let me give a point here named P. Okay, so the diagram is complete now. CD is the building, AB is the boy. From A, he is looking at the top of the building when the angle of elevation was 30 degree, and when the boy moved towards the building, at certain point EF is the new position of the boy. From E, the angle of elevation of the top of the building he found it is 60 degree. Now we have to find what is the distance walked by the boy towards the building. So it is AE or it is BF, as we can say. We don't know this distance. Let us mark this distance as X. X is the distance covered by the boy. Now how can we get the value of X? It is very easy. See here, the total height of the building was given 30 meter. This is the total height of the building. Okay, 30 meter. But the right angle triangle is triangle CPE and triangle CPA. We have to find the height of the right angle triangle. So as it is given in the question that the height of the boy is 1.5, means this is 1.5 meter. So it is clear from the diagram that this 1.5 meter will be subtracted from the total height of the building to get the height of the right triangle CP. CP, the height of the right triangle. So here, first of all, we have to give a very short description about the diagram, as I have told you in the previous session also. Write a little bit about the diagram, that AB is the tall boy whose height is 1.5 meter, and CD is the building whose height is 30 degree. From A, the angle of elevation of the top of the building is 30 degree, that is angle CAP. Angle CAP equals to 30 degree, and from E, the angle of elevation of C is 60 degree, that is angle CEP is equals to 60 degree. Let the boy walk a distance of X. So this much description we need to give about the diagram. Okay. Now let us come back to the right triangle. In a right triangle CPA, what is CP? CP is equals to the total height of the building minus the height of the tall boy, 1.5 meter. That is 30 minus 1.5. That is 28.5 meter. Base we don't know, AP we don't know, so keep it as it is. So here CP upon AP, that is perpendicular upon base, equals to tan theta. Theta is 30 degree. We have taken the triangle CPA. Now CP we know, CP is 28.5. AP we don't know, so let it be AP, and tan 30 is 1 upon root 3. Therefore by cross multiplication we get AP is equals to 28.5 root 3. This is meter as it is given in the diagram also. So the unit of height and distances will be meter. Okay. So this right triangle CPA is done. Now the right triangle CPE. In right triangle CPE, here also the perpendicular is known. We have to find the base. So perpendicular upon base is tan theta. That means CP upon EP is equals to tan 60. We know CP, it is 28.5. We don't know EP, so let it be EP only, and tan 60 is root over 3. So by cross multiplication we will get EP is equals to 28.5 upon root 3. So by rationalizing we will get 28.5 root over 3 divided by 3. Rationalized, the denominator has been rationalized. So by multiplying with root 3, both the numerator and denominator are multiplied with root 3. So here it will be 28.5 root 3 and the denominator will be 3 only. Now we can go for cancelling. So 28.5 is divisible by 3, that gives 9.5. So EP is 9.5 root over 3 meter. Now see the diagram. We know AP, we know EP. So we can easily find AE. Therefore AE is equals to AP or PA, AP minus EP. AP whole thing minus EP. So that is 28.5 root 3 minus EP is 9.5 root 3 meter. That is, it will be 19 root 3 meter. So value of root 3, as you know, it is 1.732. So put the value of root 3 here, calculate it and find your answer. Understood? So in this way we can calculate the distance covered or height of an elevated object. Okay. Student, this is the next question. The question says the angle of elevation of the top of a building from the foot of a tower is 30 degree. Top of the building from the foot of the tower is 30 degree, and angle of elevation of the top of the tower from the foot of the building is 60 degree. If the tower is 50 meter high, then find the height of the building. So from the foot of the tower, the angle of elevation of the building is 30 degree, and from the foot of the building, the angle of elevation of the top of the tower is 60 degree. Now from these two statements, it is quite clear that the tower is taller than the building, because the angle of elevation of the tower is 60 degree and the angle of elevation of the building is 30 degree. So we have to draw diagram to represent the tower and the building. This is the ground level, and suppose this is the tower whose height is 50 meter given, and this will be the building. Since the angle of elevation of the tower is 60 degree from the foot of the building, and the angle of elevation of the top of the building from the foot of the tower is 30 degree, so it makes clear that the tower is taller than the building. Okay, so here the angle of elevation of the building from the foot of the tower, that is given 30 degree, and the angle of elevation of the top of the tower from the foot of the building, it is 60 degree. Let the building be AB and CD be the tower, and his height is given 50 meter. We have to find the height of the building. Understood? So this is the simple type of question. Here you can see there are two right triangles. One is triangle ABD and another is triangle CDB. So in triangle CDB, the height is given, we can easily calculate the base using the concept of tan theta. Tan theta means what? Perpendicular upon base. So with the given height and the angle of elevation, we can calculate the base of the triangle, right triangle CDB. And then this base of the right triangle CDB is also the base of the triangle ABD. So in this right triangle ABD, we now know the base, we know the angle of elevation, we can easily calculate the height. Here also we have to use the ratio tan theta. Okay, so first description, little bit description about the diagram. AB is the building, CD is the tower. From the foot of the building, that is B, the angle of elevation of the top of the tower is 60 degree. That means angle CBD is equals to 60 degree. And from the foot of the tower, the angle of elevation of the top of the building is 30 degree. That is angle ADB is equals to 30 degree. Understood? So you have to write a small description about the diagram, then all these angles, and then we have to choose the right triangles and solve it. So in right triangle CDB, CD upon BD is equals to tan CD upon BD equals to tan 60. CD is known, it is 50 meter. BD we don't know, so it will remain as it is, and tan 60 is root over 3. So here BD is equals to 50 upon root 3. So we got the base of the triangle CDB as well as the triangle ABD. Okay. Now in right triangle ABD, we know the base, we know the angle of elevation, we can calculate the height. So it is AB upon BD. AB upon BD is equals to tan 30, because in triangle ABD this angle is 30 degree, so tan 30, which implies AB we don't know, we have to find. So AB will remain as AB. BD is already calculated, it is 50 upon root 3, so it will remain as it is, 50 upon root 3, and tan 30 is root 1 upon root 3. Therefore AB is equals to 1 upon root 3 multiply with 50 upon root 3. So by multiplication, AB is equals to 50 upon 3, that is 16 2 by 3. Therefore, height of the building is 16 2 upon 3 meter. I think this question was very easy. Hope you have understood. Okay. So in height and distance, just remember two very important things: the diagram and the requirements of the question. Generally what happens, a right triangle will be there in which one of the side is given, we have to find the other side. So here BD is common base for both the triangles, so that help us to find the height of the building, because height of the tower is given. So we have calculated the base of the building BD, and then base of the building is known, so we can calculate the height of the building. Understood? So in this way we can solve this type of very easy sums. In the next class I will give you some standard sums. There you will find little bit difference from this type of sums. Okay, so till then practice all these simple sums, and let me return back in the next class to show you some more important questions, okay, and how to solve it. So till then, goodbye and have a wonderful day.